Learn Engineering with Meera. Our today's topic is coplanar concurrent forces. So in this video we will discuss various system of forces and laws and methods to find out resultant of coplanar concurrent forces. Also we will discuss the basic concepts of equilibrium and free body diagram in the last section of the video. So let's begin. An agency which changes the position of rest or uniform motion of a body is called force. For mechanics, we can divide it into an actual physical contact like push, pull or twist, or it can be without any physical contact like in case of gravitational force or magnetic force acting on a body. There is no actual physical contact but still the body moves. Force is a vector quantity as both magnitude and direction has to be specified to completely define a force. And unit of magnitude of force is Newton. If two forces are acting on a body, it may be replaced by a single force which can produce the same effect on the body as that of all other forces. This single force is called resultant force. We can find out resultant by two methods, law of parallelogram and law of triangle. Let's consider that all forces are acting through the center of gravity of object. Now, law of parallelogram states that if two forces are represented as adjacent sides of a parallelogram with their actual magnitude and direction, then the diagonal passing through intersection point gives magnitude and direction of resultant force. Instead of parallelogram, if we take given two forces as sides of triangle taken in order, then as per law of triangle, resultant is third side of triangle but in opposite order. The magnitude R can be found out either by graphical method as we discussed, where you input magnitude and direction with scale on a graph paper and measure R with help of a scale, or by analytical method like this. Drop a line CE perpendicular to AB. For triangle ACE, R square equals to AE square plus CE square. AE is summation of AB and BE. Now put all values. AB is equals to F2, BE is equals to F1 cos theta and CE is equals to F1 sin theta. So after analysis, we get this equation to find R. Angle between resultant and F2 is alpha, where tan alpha is equals to CE upon AE. Put all values and we get this equation. When several forces act on a body simultaneously, it is called system of forces. Before we discuss methods to find out resultant, let's see various system of forces. If line of action of all forces in system pass through a single point, it is called concurrent force system. If all forces in system lie in single plane, it is called coplanar force system. If line of action of all forces lie along a single line, it is called collinear forces. Let's see the examples of combination of these forces. This is the example of coplanar concurrent forces where all forces pass through a single point and they lie in same plane. Forces acting on a beam of a building are coplanar non-concurrent forces which do not meet at a single point, as some of the forces are parallel to each other but they lie in single plane. An electric pole supported from three sides develop non-coplanar concurrent forces where all forces pass through a single point but they are not in same plane. And loads acting on a mat foundation from the building above is an example of non-coplanar, non-concurrent forces where forces neither pass through a single point nor lie in single plane. In this video, we will cover coplanar concurrent forces. To find out resultant of several forces acting on a body, there are two methods. One is by law of Polygon and another is method of projections. Law of Polygon states that if all coplanar forces acting on a body are represented as sides of polygon taken in order, resultant is the closing side of polygon but in opposite order. Suppose five forces are acting on a body. To find out resultant of all these forces, arrange the forces one by one such that the direction and magnitude of force is not changed, and also tail of force is at same point as head of previous force. Then the line joining first and last force is resultant but in opposite order. Another method is method of projections, which is an analytical method to find resultant of several forces. Before discussing this method in detail, let's talk about an important concept we are going to use in this method, and that is resolution of force. We discussed how to find one single resultant force of several forces acting on a body. But let's think of a reverse situation where we want to find out two or more forces which together have same effect on body as one single force. These forces are called components and the method is called resolving force into components. Generally, we resolve force into rectangular components so that they are perpendicular to each other. If theta is the angle between force F and x-axis, component in x direction Fx will be F cos theta and y direction Fy will be F sin theta. Now let's see the method of projections. If number of forces are acting on an object, each force can be resolved into two rectangular components, one along x-axis and another one along y-axis. As all horizontal components are in line to each other, they can be added together to find single force Rx. Similarly, all vertical components can be added to find out resultant force Ry. Now Rx and Ry are two forces acting on the object which are perpendicular to each other. So if law of parallelogram is applied to find resultant of these two forces, R will be under root Rx square plus Ry square and angle theta is tan inverse Ry upon Rx. Suppose some forces are acting on a body and we calculated resultant force R of all these forces using any of the four methods discussed previously. Now, if resultant force comes out to be equals to 0, body is said to be in equilibrium. Thus, a body is said to be in equilibrium if the resultant of all the forces acting is equals to 0. The components Rx and Ry also be equals to 0, which are called equations of equilibrium. In simple terms, under equilibrium condition, forces are acting such that the combined effect of all forces does not change the position of object. But the question is, what are the forces acting on a body? Are they only the external forces applied? If so, the effect of same force should be same on all different objects. But it's not same. Even for similar objects like a ball lying loosely on ground, if you kick it will move in direction of force. But if you kick a ball secured to ground with a string or kept on some kind of stand, it will not have same effect, but you will definitely end up having a bleeding toe. So the point is, all the forces or restrictions acting by surrounding bodies like a wall, ground, support, other objects in contact, and even self-weight of object should be considered while applying equilibrium conditions. So let's divide the external forces acting on an object in two parts. One is applied forces and another one is non-applied forces. Non-applied forces can be subdivided like self-weight of object and support reactions. Self-weight W is mass of object multiplied by gravitational acceleration g and is always assumed to be acting vertically downward through center of gravity of a body. Reactions are forces developed due to restriction to the free movement of object in any direction by adjacent bodies. If a ball is resting on a frictionless plane, it can move in horizontal direction freely, but it cannot move vertically downward and sink into the plane. So to restrict the movement in downward direction, reaction force of equal amount as weight of ball but in opposite direction will be developed by plane. Let's see another example. Suppose an object is tied to a smooth wall by a string. In this case, there are two supports. One is wall and another one is string. To find out reaction from wall, let's ignore the string. In that case, object can move freely on this plane under application of force but cannot pass through the wall. So to restrict the movement, wall develops reaction in opposite direction. Now with string attached, object can move in this direction if force is applied, but this movement is restricted by string. So reaction in opposite direction will be developed on the line of string itself. Now let's remove all the supports, replace them by reactions and apply self-weight of object. And here is your free body diagram. It is very important concept to identify various forces acting on an object while in equilibrium and also for analysis of forces. To analyze forces, rearrange all forces so that all of them meet at center of gravity of object and then use equilibrium equations and Lami's theorem, which states that if three forces are acting on a body, each force is proportional to the sine of angle between other two forces.